Okay, good day everyone. Thank you very much for watching this video. This is the final project presentation for Managing Machine Learning project course. So these are the items that the project description requires us to explain about this project. So we will begin with the problem description. We are a part of the City Council and we have noticed that the quality of the air is getting worse and worse month after month. So what we nowadays do is that when we manually estimate that the air quality is really bad, we trigger an alarm to our citizens for them to take precautions. Nevertheless, this alarm is nowadays triggered too late because it does not give citizens time to prepare for adequately planning and taking actions to protect themselves for this pollution. So what we really need is a system that's able to predict these high pollution episodes at least 24 hours in advance to let the citizens to prepare for this. So this is clearly a machine learning problem, first of all, because it's a prediction topic. We need a system to be able to predict, and it would use historical data in order to detect when these high pollution episodes will happen. Okay, this historical data will come from both from weather sensors in real time and from weather forecast. So as we have explained, we're dealing with high levels of pollution and the necessity to inform and alert the citizens in advance. So we have some outputs and outcomes. So first of all, the outcomes, the short-term measurable outcome would be the amount of people, hopefully a decrease on the amount of people that would be sent to hospitalization in emergency rooms due to these high levels of air pollution to have been exposed to that. Another outcome, but this is more difficult to measure because it's more a long-term outcome, is hopefully a decrease of the citizens who have pulmonary problems because they have been exposed year after year to this high level of pollution episodes. In terms of metrics, model output metrics, sorry, the outputs would be the pollution levels itself. These pollution levels that have been forecasted can later on be compared with the actual pollution level values to evaluate the model performance. So in terms of validating the plan, the conceptual solution for the final users, here it's very simple and useful to use a mock in which we would show the users how it would like the application that they would have in the phone and how this application would show alarms. So for example, we can initially propose to the users that we may be able to send three level of alarms with three different colors, for example, orange, red, and purple, depending on the level of pollution that we have in the air. And the users can provide feedback that they may prefer, for example, us to show the level of pollution in a scale of 1 to 5 instead of colors. And this all would be done before we actually begin working on the model itself and the algorithm. So in terms of the infrastructure, first of all, since the data is coming from very different kind of sensors distributed along the city and weather focus, we consider that the best is to have a cloud solution for both for the data and also for the computational power. That would also provide us enough computational power for us needed and on demand and deal with high availability issues. And latency is not a problem for us in this prediction model, so it would fit to BH. In terms of user interface, it would be an application that citizens can download in their cell phones from Google platforms, Google Play platforms, or any other platform for free. In terms of data pipeline, that's a very difficult and interesting topic because we would receive data in very different formats. So we have to unify and standardize these data before this can be used as input for our features. And in terms, of course, our features would be the data, the actual time or real-time data from weather parameters such as rain, sun, temperature, wind, etc., and also the forecast data. And the model training I would recommend that if possible, if the computational power allows it to be online. And the reason for that is because we need a system that can quickly adapt to slight changes, because some small changes in some features, such as the wind direction, can have a drastic output in the model. Because, for example, if the wind changes its direction, it may make that a nearby solution, a nearby city that creates a lot of pollution, this change in the direction of the wind may make that this air comes to our city, right? And in terms of predictions, we can do it as a batch, saving some computational power. And because we do not really care too much if we send these alarms 10 minutes in advance or 10 minutes after that, it has to be more or less 24 hours in advance. Finally, in terms of possible issues, yeah, the model performance can degrade quite easily due to data drift and concept drift. Data drift may be a change in behavior of some features, such as, for example, the temperature is pattern and behavior is changing month after month and year after year due to climate change. Similarly, rain patterns are changing as well, so we have to adequate to this change in constant retraining the model. And finally, concept drift. New features may appear, such as and some features may disappear. For example, a new big industry can be built very, very close to the city or inside the city itself, and um, these buildings may create a lot of pollution, changing a lot the relationship between features and outputs. Okay, so all in all, I hope that you like this project, you find it interesting, and yeah, I enjoyed it a lot, of course. So thank you very much. Thank you for watching. Bye.